a good sheet there that shows all those things, okay? You're going to take the height over 2, okay? Multiply by each respective y. Remember that I drew a little sliver and then showed you what each portion was? And it's going to be the first and the last. Remember I wrote sometimes, I didn't know if it confused anybody, I said the first plus the last plus 2 times the rest, okay? Because each one of them is going to repeat except the first and the last, which is obvious. So that's why they say I went first plus 2 e sub iy, okay? That means all the y's, and I just wrote this here, okay? And that's what's here, plus the last. So using this function, you're going to take what you found for the height, which is pi over 6, divide by 2, and here we go. We just put in a 0, and then we do 3 intervals after the 0, okay? So that's 0, you put a 0 in for sine of x. Everybody knows the sine of 0 is 1.
Yep.
Is it 1? Let's see, cosine, sine, right? And it's 1, 0. So yeah, and then you take the log of it. The log of 1 is 0, right? E to the 0 is 1, right? So then that's 0. Then you put pi over 6 here, and pi over 6 is 30 degrees. And you don't have to know what pi over 6 is. And if it's the sine of pi over 6, which is 30 degrees, should be 0.5, right? So it's the natural log of 1.5, and then you get a value. Pretty good? Then you do the same thing. I'm just showing it right here. I said, well, then that's 2, right? So this is pi over 3. Put pi over 3 here, add 1, you get this guy. All right? Then you get this guy, then you do the same thing as well. All right? You put another value in there. Remember, it's each interval of pi over 6. So you add pi over 6 to this guy, add pi over 6 to the next guy, add pi over 6, etc., etc., etc. You can keep going on if you wanted to, right? But you want to go to this interval, which is pi over 2. The first and the last. And everything else is twice the stuff. Not bad? And you're adding them all up. Now notice that this is 0.6931. And if you would do me a favor and take the natural log of 2, is it 0.6931 on your calculator?
0.693.
And what's the last digit? The other digit?
1.
3, 1, right. And actually it's going to be this repeating, okay? All right, there's a Taylor series that's involved in that. You don't have to know it. And so on. So I just showed this right here, what's going on. They multiplied by 2, and then added the first and the last. And they wanted it to decimal points, right? Decimal points. And so they get roughly 0.72. Yes, sir?
Could you do the first problem, because for some reason I'm not sure where they got their answer from.
All right. So, yes, ma'am. You are lost. You weren't here last time. All right. So I did have some stuff on this, okay? I'll try to go over it again. So the first thing that you want to do is find the height, okay? So that means here's the formula right here. You take the upper bound minus the lower bound and divide by whatever number of segments they want. The more segments, the more approximate and better it is, right? Because there's less error. So they wanted 3, right? So that means I take pi over 2 minus the 0, the bounds, divided by the subdivisions or intervals, and I get this as my height. Pretty good? Now, she's like, okay, we stick it in this formula because it's the trapezium, so it's like a triangle, so to speak. So we take this interval, if you want to call it that, or the height, divide it by 2, and multiply it by every respective, y sub naught. So that means when I put pi sub 6 here, right? That's my first guy right here. I put pi sub 6, I put pi sub 6 right there, and then I get a respective y value. First of all, I put 0, right? The lower bound. And then I add every interval of pi over 6. And it said 3 intervals, 1, 2, 3. Okay? Remember, it's going from 0 to pi over 2. You see it? Between these two guys. Okay. So it's going between 0 and pi over 2. So that means I put a 0 in here, and then this is the natural log of 1. Yeah, right, natural log of 1. And natural log of 1 is e to 0, which is 0. And then I put another value in here, which is pi over 6, 30 degrees. And then I add 1 to it, and I take the natural log, and I get this decimal. This is the multiplier that I'm going to use here. So the first value was 0 here. Then the other one, the formula calls for it because each of these repeat. Because you're going to have like another triangle, right? Or rectangles. This y, other than the first one, this y1 is repeating, right? Because it shares. Then the y2 is sharing, and etc. And except the last one, because that's the last portion of the fence. So we take the first value times 2 times the second, plus 2 times the third, and then we just add the last value. And then when we do all that, the integral of this is approximately, or the numerical method is approximately 0.72. Or better? Of course you got it.
Is this stuff going to be on the original?
Could be. Yes, sir. You want me to do one on the sheet or something?
So would you be able?
Maybe. I don't know if I'm wasting my, not wasting our time, but if, it's not that tough though, right? I have to give you the formula, but it's not that bad. Yes, ma'am.
Yesterday, the way you explained it with the first and, or the middle terms,
With these guys here,
yeah, you didn't separate them like that.
I didn't have to because I can just factor out a 2, right, and add them. This 0,
Yeah.
0.4, 5, whatever.
Okay.
4, 0. I can do the same thing, okay? Because I pulled out a 2, right? That's okay. Either one is sufficient.
Okay.
Doesn't matter.
Doesn't it make a difference? then?
No. If I had 2x plus y, 2y, isn't it the same thing as 2x plus y? Factor out a 2 between those two things, right? Greatest common factor.
Can we do the one from the review sheet then?
Can you do the one what?
From the review sheet.
If you want to.
Okay. Yeah, it doesn't make a difference.
No, it doesn't. See? Yeah, because you're just adding, right? You have to multiply first before you add. Which one do you want to do? Or I think, this one right here? Yeah. Which one?
It's like number 2 on the review sheet.
Number 2 on the review sheet, okay?
It's like in the back though.
Is it question 2?
Yeah.
So it's, okay. Are we all right here?
Mm-hmm.
So you don't want to do this one? Okay. Review sheet, okay. So this is number 2 on the review sheet, yeah? All right, so the integral of 3 to 0 of the square root of 2 to the x dx, right?
So,
Is this the right one?
where is that one?
Isn't that the one you asked me?
I'm
Number 2
taking-
is on the front.
No,
I'm
on the.
confused.
It's like in the back.
I don't know
I don't
which
know
one you're
how to.
talking
There's like a lot
about.
of numbers here.
Oh, is it? Is the,
I don't know, I gave
This one?
several examples.
That one.
Which one's you doing? Oh, the one, the rep,
Mr.
didn't I do that yesterday?
No, I don't think so.
No, I didn't
It's
do
like
that.
on the last
I did
page.
that one last time. That's fine.
Wait.
I did that one last time.
It's on the last
Didn't I do
page.
that one, 3 to the x?
Oh, this.
Maybe with red period.
Yeah, we didn't.
Maybe, okay. I thought I did this one. Minus 10?
The
dx?
x of n and then in parentheses the x cubed n plus 100.
Who wants to, didn't I do it?
Yeah, we've done it.
You want to try it? Hit Billy or whomever. Come on up and go ahead. And then I'll walk around and look
Because
important.
we did it doesn't mean.
Oh,
That's
yeah.
right.
I did it.
Who wants to put it up on the board?
Where did it?
I don't know. I did it.
You have a
But
problem?
yeah, go ahead. And I'll walk around and try to help
Billy,
others.
you want to be my calculator?
Calculator?
I'll give you one.
All right, you two do it.
You don't feel
Demonstration of work, okay? All right, so I'm walking around and looking semi-important, okay? Who needs help?
Down, but I didn't. I hear
I don't know what to do.
something.
Mary, I just made it
I'll
up.
look grab it.
I did it yesterday.
Okay.
Oh, we haven't done this one.
I thought we did.
Yes, we have.
Thank you. She copies
We
everything.
did, yeah.
Oh, is that the one?
Okay.
Oh, it's from
I don't know where it
Oh,
says
okay.
the
The interval is
said
what?
It's 3.
I think it's 3.
It is.
I just didn't write the interval.
Okay, I don't see it on here, but just know n is 3. That would be given to us, right?
Yes, absolutely. The interval
Okay.
It'll
is
say
everything.
the,
So it's just-
something about intervals.
You always have the interval, okay? Don't worry about that.
I think it got cut off.
Yes, use the trapezium rule to find intervals. 3
Okay.
intervals.
First off, we want to
Approximate.
find h. So we do b minus a
Over n.
over n. So that's 3
Yep.
minus 0
Over
over
3.
3, which becomes 3 over 3, which becomes 1.
Correct.
That's nice.
Do you want me to
Rocket
down
science.
for that one?
Yeah. Just in case.
High bound minus low over the number of intervals. Intervals, okay? Yeah.
So now we have the x, and then we have the
Who needs to see it as well? Who needs to,
equation
like,
for the
yes,
number.
no?
So we do 3 to the x
It has to be absolute then.
minus 10.
He's right, yeah, yeah.
Because it's all positive.
Yeah, you're right.
Okay, so now that we got that, now we do the intervals. Since there are 3 of them, and it's from 0 to 3, and the interval is 1, we know. So it starts with 0.
Yep.
Yeah. 1, 2, and then 3. So
Mhm.
the whole way through the bounds, and then
He's on the ball. Now I can't say anything.
different
I gotta
handling
sit
them of
back.
that.
Yeah. So,
So plug
3
it
to the
in.
0 is 1 minus 10 is 7. So negative 7 is
Give him a chance. Give him a
1
chance,
minus
Billy.
10 is 7.
1 minus.
Do the 3 to the
Okay,
0
nine.
first.
That's something I do.
It,
Alright, yeah,
What
1 minus
time
10.
is it?
So do we make it absolute value?
yeah.
After you're all finished, then
Okay,
you
yeah,
have some
because
value.
you can't have a negative
Hem does.
Yeah.
negative space.
Yeah.
Alright, so
Just
that's
like you can never have that area thing. That's what we're doing.
Well, area, right, area is going to be always
Alright,
positive.
1, so it's 3 minus that, so
That's
there's,
the seven.
there's the 7.
There's the 7.
2, 3 squared, 9, minus 10, 1, and then cube 27, so 17. Right?
Everybody okay how we got those?
Yes.
Plug chug.
So there we go.
He's the man.
Then
Keep going.
we do the h, which is 1 over 2,
Yes.
then times this, and 2 times.
Label your first and last.
Yeah.
That helps out.
First, last, and then
Middle.
the
Middle
rest.
dudes.
Yeah.
FML.
You right.
Me when I do this problem.
Oh, I missed it. I'm sorry. Nothing. Keep going.
FML.
No, that I
I don't know what happened.
First, middle.
Oh, okay.
We'll tell you later.
Oh, yeah. Never
Now
mind.
I
I know what it is.
But 9
I got it now. Never
plus
mind.
2 times.
Remember your-
I'll move when
You're
I
being
have it.
recorded.
7
Okay.
plus 1.
7 plus 1,
And then
and
plus
then plus
17.
7.
See how we combine those? It's
Put
okay,
it in
right?
parentheses.
Close the other one. You got it.
There we go. Alright, so that plus that, that's 25, and then
21 in the middle. So 21 total. Excuse me.
21 is the answer.
Or
21's the
21's the answer. 42 divided by 2 is 21.
after you've done the half?
Yeah.
All
Yeah,
that
okay.
junk is 42 divided by 2 is
So
21.
this is
Correct.
42.
Oh yes.
Right.
Okay. Wonderful.
Really easy.
Easy peasy lemon squeezy.
And
Okay.
there we go.
Yeah.
Yeah.
Isn't that not bad?
What's the calc part of this question?
So we
Find
don't-
out.
Well, there's no.
The first,
This is the
middle, last.
trapezium. I mean, this is a Calc 2
So
question.
we don't
Okay,
have to-
literally, okay. We could have done this.
What? First.
Okay, we could have done it in algebra 1, but literally the only thing that's calculus is probably just that,
The
integral.
say over n.
Yes.
That's
Yes.
the only calculus
the only
part
calculus
is
portion,
algebra.
They use like this fundamental theorem of calculus.
That I'm
deal.
not remembering.
And then you,
Can you integrate that?
Yeah.
How?
Yeah.
With the x and the.
You go u is 3 to the x minus 10 and du.
do you remember that?
Yeah. Yeah. You
But it's
can.
absolute value.
Vaguely.
I
Yeah,
have,
you can.
I have
I do substitution on it. U
I don't
du.
know.
That's a thing.
You get it.
yeah, we don't use substitution, we use,
Let u equal that guy, then
that
du.
Ty's method.
Is that what the x is?
Yeah. Okay.
It's the chain rule, it's the chain rule one.
Yeah. Yep. Good thing we're not asking that one. Okay. He's 100% correct. Okay. Does that help? Yes, sir.
So there's no
First chain
actual
rule is
integration.
Ty's method.
No, not at all. Nothing. Because you're just doing area.
Yeah.
And then you're going to miss a couple stuff here, okay? You saw the area under the curve, there's like these little spots that you miss. And then later on, Leibniz came out and told you how to actually integrate it all and get the exact answer. All right? All right, any questions on this? Not bad?
How would you integrate that like normally?
I use substitution.
Yeah, like I don't know how.
Can you do it real quick?
I can, but I want to do one that you might see next week. I can do it later if you want, okay? Yeah, of course. All right, this is okay?
Yeah.
I'll leave it up there. All right, so you got one that's on there. You know that I'm going to ask. Everybody know what I'm going to ask, right? Or
Yeah.
this. So you guys are okay with Mrs. K? We might do a Miss K question, so to speak, if you have questions. All right? So let's do one of Sammy's ones, okay? And I just picked one arbitrarily. All right?
From the
Okay.
review sheet?
From the evil review sheet, okay?
From the
It's not
test
evil.
review sheet.
Yeah, the test review sheet, it has Sam's as well as Mrs. K's, right? And you turn the page and then you got Mrs. K, you got Sammy's stuff, right? So this is number 6.
Number 6.
Number 6, it's a classic question, okay? 11 points and then there's 8 here, okay? I'm gonna do the 8, you should be able to do, I'll help you a little bit with the 3 and 4, okay? But to get the meat of the meat and potatoes, you wanna get the 8 out of the 11, right?
This one.
Yeah, yeah, with the little table and so on.
Okay.
It says a survey, right?
Yeah.
So a random sample of 50 households from Brandley questionnaire, right? So number of computers and households and all that other stuff. All right, so it goes like, 0, 1, 2, 3, 4, anything greater than 4. Who cares about 4, right? Because it's 0, right? And then everything else. So it says calculate the unbiased estimate of the population mean and the standard deviation. So, how do we get the mean? Don't be Okay, well, add them up and divide, not by 5.
The total that you have.
Oh.
Isn't this a frequency thing?
Yeah,
Wait, which one?
let's do the mean. Let's do the unbiased
Everything else is obviously.
estimate.
another number 6 that's the exact same thing.
Alright, so hold on, right? X bar, and it's on your sheet for, it should be, I'm pretty
There's
sure.
so
it
many
is.
number 6s.
The
Yeah,
unbiased,
now I know. I was
Everybody
thinking
okay
of
now?
other number 6 that has
All right.
type of
That's
testing.
the others.
look familiar?
Mm-hmm.
Okay, so far so good? Yeah? Now, what's on the bottom? How many total house, no,
Oh,
no.
wait, what?
How many total households or whatever it is, right?
Yeah, 6.
No,
Oh,
50.
You know, you put it off there, but.
Me too, man.
Okay, now, you're gonna do something like this, right? Watch what I'm gonna do, right? Pretend you're looking at the chart or the table, ready? Watch. Once again, right? You're looking at the table.
Multiply?
Yes, and add, right? It's frequency, right? So that's gonna be 0 times what? 5, right? Who cares? Next one's gonna be what?
1 times 12.
1 times 12, I'm just showing the path here. Plus
2 times 18.
2 times 18. Plus,
3 times 10.
or you're right. Plus,
4 times 5.
plus, 0.
Yeah.
Whatever, right? Because greater than 4, they don't have 4 computers in their household, right?
why the 0.5 again, I'm sorry?
Why the 0.5? 0 times 5, sir.
Oh.
Okay? Look, the point's a little higher, okay? All right, someone tell me what you get for the top. 98 over 50. Answer?
This is,
And it's going to be exact. Excellent. So this tells me the average households out of 50, right, would have how many computers roughly? If we round it. 1.92, right? 2. So we give them 0.4 just for the heck of it. Yes, sir.
Or it's like a computer and a laptop.
We're not going to go, yeah, if we cut it in half, right? You ever think about houses and so on, they have 3.5 baths? What does the half really mean? What's it missing?
No.
No tub.
Yeah.
Yeah.
Right?
Bathroom without a shower in it.
Yeah, right, yeah. So they still call it a bathroom.
you mean a throne room?
Right. Well, I don't know what you verbiage you guys use at your house, okay? All right, so that's X, okay? Okay? It's a something experience, okay? Yeah. Any questions so far? Now the next one is standard deviation.
All right.
You know it's going to be that evil thing here, right? Remember?
Oh, no.
Oh, yes.
Variance, right?
Wait, so it's part I 1.96.
Sorry?
We have to find the standard. It wants variance.
Okay, fine.
So we just gotta find S squared. That's even easier.
That's even easier. So 1 over n minus 1 is what? 1 over? Hello?
9.
50 minus 1, which is?
49.
Okay. I can do this part here, right? We just figured out E of f of x, right?
Yeah.
Which is?
98
Good job.
over 50.
And what are we going to do with this 98?
Well, square.
Going to square.
Good, good ladies and men. Now, you got to figure out this evil stuff here. What's this one right here?
We have to square all of them individually first, or we square?
No, we're just going to square this one, and then we're going to take this each individual thing and square it, right?
Okay.
Let's see if I did this one. I think I did. I got to do this solution here, which is a pain in. Yeah.
Mr. Murm.
Yes, sir?
So is X the number of computers or households?
X bar is the number of average of
So
computers
what's
per
the-
household.
The X, like what do we square?
X is okay. It'll be X here on top is the number of computers, but X bar is the average computers per household,
N is the number of households.
and is the number of households. Right. So what's this number right here, viewer?
So that's you square the individuals and then sum them up.
Yep.
I have the 98 squared divided by 50.
Okay. That's good. I like that portion. What's this guy right here? Need a number here, right?
Yeah.
What is it?
So,
So the sum
which
of all
one
the
is X?
Hold on. X is right here. X right here. We got
X.
X. Okay. That's on top.
So it's the, I got 30 then.
30
So, yeah.
then what about the greater than 4?
The ones on top? I'm
can't be 30. I mean, 30 minus this is going to be really
Yeah.
good. Yeah, hold on. Let me ask you this next question. Go ahead.
Is it 55?
55? No. Any others?
Oh, we So we're squaring the number of computers?
So it's going to be what here? So
Yeah, we don't know what to square.
we don't know what we're squaring, right? Okay.
Yeah.
So this was 98, right? Okay. So I believe, if I'm right, I'm not sure, because we got 12, 20, 38. If you took the bottom numbers, oh, that's not going to be. It's going to be too big.
Or is it gonna be, is it,
Go ahead. I'm trying to figure out how I got the answer.
so it's not like 0 squared plus 1 squared?
Well, no. If it was if you did 0, 1, 2, 3, 4
Is it
squared,
618?
it what?
Is it 618?
No, it's too big. I think that what you, okay, 1 squared times 12, 2 squared times. Okay, do this for me, okay? Go 1 squared times 12 plus 2 squared times 18 plus 3 squared times 10 plus 4 squared times 5. Tell me what that is, please.
So that's how we do it.
I'm seeing, I think that's how I did it. That's 12. That's 30. Right, that's 90, excuse me. That's 16, that's another 90. I think this is it. 4 times 18 is what? 32 plus 40, 72? I think this is it. Yeah, this is it.
Yeah.
But why? Is it 254?
Yes. Okay, go ahead.
Why is that what you do?
Because if you remember, you have the box here, and it's like, for example, it has 0 and 5. Well, 0 times 5. So here you're doing what's called what is it? It says to square each one of them. So you're squaring this guy times its frequency. That tells us how many things are there. So you're really doing something from last time, which is what? Expected value. I think it's expected value. So you take the 0 and you square it and multiply by the number of things that you see. Then you take the 1 and you square it, and then you multiply the number of households. So this is the portion to get 254. So you take the top and square each one of them and multiply it with its respective bottom, and then add accordingly. And that's where you get
I got that.
254.
Yeah.
What's
And then the answer is,
Give me 2 seconds.
I got
No problem.
1.2.
pardon me?
Is it 1.22?
Yeah.
1.22 is pretty good. I got 1.26.
2.6.
Yeah.
Okay.
All right. Not bad so far. Now, if you wanted the
I got
standard,
1.26 also.
yeah,
Oh,
and
wait,
if you
that's
wanted the
before
standard,
the
I'm sorry, if you wanted the standard deviation, it's the square root of 1.26. Okay.
Yeah.
Not bad. This is a little thing from last year. Oh yeah, I forgot everything last year. All right. Not bad so far. Yeah, because the other numbers were too small. That's what I was doing. That's why I was like, yeah, you have to square them. Because you're doing a like a frequency thing. All right. So next one, double I. Right? We're almost finished. Right? How much time left?
4 parts for this one.
Lots of time.
Lots of time. Good. All right. Now it says to conduct the test, right? The hypothesis test. So what's all the information that we have? Do we have n?
Yes.
We have
Do we have now sigma?
Yes.
Or- which is now the square root of
1.1.
1.26, whatever that is. Okay, good.
we have x bar.
X bar, whatever that is.
1.96.
1.9.
Yeah. Is it?
And we have the original one, which
1.96?
is 1.66.
That's the mu.
And that's mu.
1.66.
1.66. What else do we have? Anything else? Or we don't-
Alpha.
What's the
Alpha is
Alpha is 0.05.
Yes.
Yep. And then that's the 5 things we need.
And that's all that's usually that you need, if I'm right. Okay?
Yes.
All right, so the first thing is Merry Christmas, and Santa says,
Ho, ho, ho.
so you have to say
Ho, ho.
ho and ha.
So,
Remember, it's a hypothesis test.
yeah, so, what are the,
So what do they say that they think that the average
It's gonna be a
computer...
two.
mu equals 1.66.
U equals
We
1.66.
say heck no.
And you are proving that it doesn't.
Yes. It doesn't
And
specify
since what type of test?
It's
Two-tail.
So we cut out that.
But we're proving it's more than that.
that.
You're saying, I don't believe it, right? I don't believe what you're saying.
So we're gonna use 1.96 as our Z.
Yes.
The man. Now the test statistic, right? TS, so to speak. They call it the test statistic. You're going to do what? Z. And we're going to go X. Is it X bar minus mu?
Yes.
Over
Or
sigma times the square root of n.
Or divide by the square root.
Just the square root of everything.
Or just the square root of n, right?
Yeah.
Either one, right? Or
Well,
S.
you said
Well, you need
times
to
the
square
square
to
root.
everything, because we already have.
Yeah, okay, it doesn't, right, it doesn't matter, okay? So this is how I said 1.96, you'll tell me differently. 1.66 over, yeah, whatever it is. And I did the square root of everything, okay, is that all right? It doesn't matter. 1.26, whatever,
Yeah, that makes sense.
over 50, because I already had it. Doesn't matter how you do it, right? And ladies and gentlemen, you're gonna tell me what you get approximately.
So.
Now it's cake, right? Now it's like nothing. Not bad. You feel all right? You got the tissue box right there. 1.89, the lady says.
Move it past.
1.88 change, right?
Yes,
Can't reject the whole.
we can't reject.
Whoa, 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 hey, don't get so serious, right? So you know that this is negative 1.96, you know I'm gonna wanna see that, 1.96, right? Because alpha, right? That's alpha over 2, negative alpha over 2, and then alpha over 2. There's your critical stuff, right? That's your critical value, that's your region. And you guys said you got what, 1.8?
9.
So he's over here. Failure to reject or accept, right? All right, not bad. Or do not reject is fine. I like FTR, right? It's like in NFL, they go RPO, run pass option. Okay. Hey, don't start. All right. So now you wrap it up. What do you say?
Failure to reject.
Anything else?
Don't have enough
There's not
significance.
enough.
There is not enough evidence, not stat sig, to do what? Reject the null. Or to
Okay.
reject the mean, right? Yes.
I know you explained what positive, false, or false positives and false negatives are,
Yes?
but how do we correlate it with the information that we got?
okay. All right, so-
'Cause 4.3 is what that is.
All right.
I think that's why I got a 92 on that test.
All right. So we know this answer, right? So this is the interpret.
Yeah.
I'm listening now. Yes.
I always think about Rosenhan when
Rosenhan?
yeah, the experiment with the schizophrenics.
Yes, keep going.
We learned about it in Mrs. Alaka's class where he and a couple people were like, oh, I think I'm schizophrenic. They got admitted they weren't actually schizophrenic. Then they go back and say, by the way,
By
we're
the way-
sending our people to you, so watch out for that. Let us know if you think they're ours. And they never did. And they got a bunch of calls. It's really interesting.
It's a great experiment. It's a classic psychological
The
experiment.
way I think of it is Mr. Murmer said, congratulations, Mr. Murmer, you're pregnant. And
Everybody remembers my name.
congratulations, you're not pregnant.
And then
it was
you're
like,
pregnant.
name got pregnant later.
Type 1 is the false positive, type 2 is the false negative, right?
Yeah.
All right, so you know that the not is true, right?
Yeah.
Okay.
Makes sense? So, if it's true,
Type
Right.
2.
There wasn't a type 1.
that's right. So, there isn't, say it again,
There was not a type 1.
it's not a type 1, right?
Yeah.
Because the not's true. So, it's not possible for this to be a type 1. So, number 3, not possible. Why?
Because it's true.
Because in
Because
the,
the not's true.
yes.
I can't do anything on that yet, right?
No, sir.
Makes sense. No siree Bob, right? Because the mean didn't change. Now,
And now it says state what is meant by type 2 error.
all right, so you got, right, it's playing devil's advocate, right?
I hate it.
I know you do. You look at what you have, and then you decide.
Type 2 is false negative, right?
False negative.
So what does that mean?
That means we didn't reject what we needed to, right?
Right.
But we,
So that means it says this, type 2 is when you conclude the mean of number of computers per household has not changed, but then it does. What it says. So you remember the little box I had? I showed type 1 and type 2?
Yes.
This is the type 2 error. This says that what? Well,
You shouldn't reject the whole.
you shouldn't reject, yeah, right, good.
In the test, we rejected, or it was failure to reject H sub O, when in reality, the H sub A was,
Yeah, you do the opposite of what you're
Yeah.
supposed to be doing, right?
Uh-huh.
So you know that this one's true, so it can't be a type 1. But you can have a type 2 error because you're saying the counterintuitive is true,
So
although
we're
it's
saying
not.
we didn't reject when we should have.
Correct,
so how do we know?
because of this. This tells you. What happens if it was over here? Then it's a type 1. You see what I
Okay.
mean?
So if it's
So type
inside,
2,
It's inside, it's a 2, right? You reject because it's a 2. If it's not, then it's a 1.
so if it's inside, that
Yeah.
means we could
Look at that little,
reject it.
right, look at that little box that I had
If
here.
it's a false negative, that means we should have rejected it. right?
Right.
Yeah,
How do we
false
know
positive,
that we
yeah.
should have
False
rejected?
positive.
It'll
right.
give you information.
It'll give you right there. It tells you,
Where
right?
does it give us information?
So what's the
Right
answer?
here. I just told you the answer. The answer is
It'll be like,
type 2 error. We
this
can
guy
conclude.
did the test and found that this was the real
Type 2 can
case.
be included.
Right, because it's in between, right? It's
Skipped over it.
here's your 1.89 and 1.96. Bless you. He's inside there, right? He's inside there. So, oh, good catch. So it's a type 2 when we conclude the mean of number of computers per household has not changed, but it did,
Okay.
right? Because that's what you're looking for. This one didn't happen.
Okay.
Type 1, type 2. I know it's a, read over it, it'll be better. I'm serious. I gave a lot of stuff on 1s and 2s. All right? And it's not the big bulk of the answers anyway, if you think about it. The big bulk of it is here and for the test.
That's 3 points out of
11.
Yeah.
What's that? 0.09, so that's 27%. 0.27 repeating. Is that right? 3 over 11 is 0.27 repeating, yes?
That's a pass on the camera.
Missing that.
Am I correct? Well, I see what you mean now. But type, just read what I did there, and then I gave those examples. But it's based upon what you find, right? And then you interpret it on 1 and 2.
Okay.
Better? I'll go over it again tomorrow, but I want you to look into it a little more. Yes, sir?
If you rounded those numbers at like any point, there could have been a chance that you would have gotten something that was outside of the brackets since it's so close.
No, because it's, I mean, if you round it, it's still 1.9, right?
Well, I mean, like
If you round to there, let's see, okay.
in your calculations, if you like,
If you rounded all these,
yeah,
and
and
then
I
rounded
only
that
used-
stuff, then there's a chance that you.
there's a chance that it pop over.
Yeah.
See,
Yeah.
the thing is that I only used 1.26 and I got 1.889.
Yeah,
I always go with-
1.889.
I always go to 6 steps more.
Oh yeah, you're like NASA goes to 9, but yeah.
I also
You're-
don't think that they're going to give us one that close.
No, they won't. Okay, it's a good question. You know, sometimes you're on the border. Then what do you do, right? Yeah,
really
exactly.
like-
Then you got to go exactly what you said.
Yeah.
Okay, it's so close. You know, it's in the neutral zone, right? Yeah. All right. Any other questions? Not bad. It's time to go.
Not
Party
yet.
is such sweet sorrow. All right, so tomorrow we'll do dealer's choice. I'll let you guys look over the review, and I'll answer any questions that I can do.
Ryan,
All right?
I can't do
You know this. You know the anatomy of what's going to be asked.
I
Okay.
can't do Wednesday or Friday for